guys, in this video we are going to discuss secondary cells. We will take a look at the nickel-cadmium cell and lead-acid battery. Secondary cells are galvanic cells that must be recharged before they can be used. They also can be recharged many times. In the charging process, the spontaneous feasible reaction that produces electrical energy is reversed. In other words, the charging process needs outside source EMF to occur. Here is a simple animation shows a typical secondary cell. During the discharging process, the electrons flow from the anode to the cathode, where the anode is the negative electrode and the cathode is the positive electrode. On the other hand, in the charging process, we use a battery as the electrical energy supply, so the non-spontaneous reaction can occur, and the products can be converted into the reactants again. So we have some examples on secondary cells. Our first example is about the nickel-cadmium battery. The active components of a rechargeable nickel-cadmium battery are nickel hydroxide at the cathode and cadmium at the anode. For the electrolyte, usually potassium hydroxide is used. Due to their low internal resistance and very good current conducting properties, nickel-cadmium cell can supply extremely high currents and can be recharged rapidly. At the anode, cadmium loses 2 electrons and combine with hydroxide ions to form cadmium hydroxide plus 2 electrons. At the cathode, hydrated nickel oxide is reduced and reacts with water to form nickel hydroxide and hydroxide ions. We are moving into our second example, which is lead storage battery. The battery is composed of 6 cells in series to give an overall 12 volts supply. In the discharged state, both the positive and the negative plates become lead-2 sulfate. The electrolyte loses much of its dissolved sulfuric acid and becomes primarily water. So the reactions of the cell are as follows. At the anode, lead loses 2 electrons and reacts with hydrogen sulfate to give lead sulfate and 2 electrons. At the cathode, lead-4 oxide gains 2 electrons and reacts with hydrogen sulfate to give lead sulfate and water. Combining these 2 reactions, so we get the overall reaction as follows. So let's move on to the charge chemistry of the battery. In the charged state, we use an outside source EMF so the non-spontaneous reaction can proceed. Unlike the discharging process, the anode and the cathode signs will be reversed, so the anode will have a plus sign and the cathode will have a negative sign. At the cathode, electrons are being pushed into the cathode from the EMF source. The cathode here has negative sign. Lead sulfate gains 2 electrons and is reduced into lead again. At the anode, electrons are being pulled out of the anode by the EMF source. The anode here has a positive sign. Here lead sulfate loses 2 electrons and reacts with water to give lead-4 oxide. In the end, don't get confused. The anode is the electrode at which oxidation reaction occurs, and the cathode is the electrode at which reduction reaction happens. That's a general rule. Please guys leave a comment down below and subscribe for more tutorials.